Hello everyone, I welcome you all on this wonderful platform that is BYJU'S exam prep. So guys, this session is related to the Ground Zero series, and today we are starting the subject which is production technology, which is the highest weightage subject. So I myself, Dheeraj Sardana, I am having around 11 plus years of experience in this field. So today we are going to start with the topic named as welding. So guys, everybody would be aware of this term because this is something which is having application in our day-to-day life. So welding is a process of making permanent joint using two similar or dissimilar materials with or without the application of heat or pressure or both. There are some processes like arc welding where we are using the application of heat. There are some other where we are going to use the application of pressure like you can say the resistance welding and also the solid state welding processes. So guys, today we are going to talk about the principle of arc welding process. So my dear, when we are talking about the arc welding process, you know that first of all we are going to have a workpiece and an electrode. You know, generally electrode is made up of a wire and above which some flux powder coating is done. It looks like similar to the Diya Salai which we are using in the Deepavali kind of festival. And guys, like whenever we are having the electrode and workpiece, whenever you are taking electrode towards the workpiece, because both of them are subjected to some power source, which may be AC or DC depending on the application and process. So because of that, whenever electrode is coming towards the workpiece, you know, in between air is there. Air is an insulator. So because of that, even though potential drop is provided, current cannot flow directly. So when electrode and workpiece are coming together, the air between the gap reduces. So there is a point comes where the potential drop which is provided by you externally is capable of making the air to be ionized. And when the air gets ionized, converted into positively charged ions and negatively charged electrons, then my dear, as per the law, you know that opposite charges attract each other. So whenever you have provided the power source, maybe workpiece is positive, electrode is negative, maybe electrode is positive, workpiece is negative. Both are usable in different applications. For the timing, let us assume that workpiece is positive, electrode is negative. It is said to be positive or direct current straight polarity. So electrons will be attracted towards workpiece and ions will be attracted towards the electrode. So whenever they will be moving towards each other and whatever these things is going on, because of that arc or spark will definitely created. And because the environment is ionized, electrons are flowing, circuit is a kind of complete one. But yes, because of that arc will be generated. And when arc will be generated, that arc will be utilized for first of all the wire of the electrode gets melt out because it is having the minimum melting point temperature. After that the flux will start melting because flux is chosen in such a way that its melting point temperature is higher than the electrode wire. Obviously there is a purpose behind that, and because of that the mixture of flux and electrode material, they are just coming in the form of a droplet and went into the groove to make the welded joints. That is the principle of welded joint. But my dear, when electrons and ions, electrons are moving towards workpiece, ions are moving towards electrode, then my dear, during that some of them collides also. Because of that ultraviolet rays are generated. That's why we are always advised to wear the glasses during the welding process. When electrons are moving and ions are moving across the potential difference, so obviously they have some kinetic energies with them. It is observed that the kinetic energy with the electrons are you can say 2 times than that of the ions. So that is why whenever whenever the electrons are going to the workpiece, they are having 2/3 of total energy generated. So 2/3 of energy is going to workpiece here because workpiece is positively charged and workpiece is becoming anode. Rest 1/3 energy with the ions is going to the electrodes. Obviously, we will be considering heat losses in the upcoming classes. Right now, we are just looking at the principles. So, whenever first of all electrode wire melts, then flux melts, then the mixture is coming into the groove and weld is getting performed. So my dear, in this welding, if you see the weld bead geometry, there are three regions. First region is the weld bead, which is the solidified molten pool. Second is the metal itself, which is, you can say, the parent metal onto which you are making the welding. Third one is the region which is near to the welded part is said to be heat affected zone. Actually, out of these three regions, the weld bead is said to be the strongest one, because whatever the flux is coming, it is having some alloy content for the parent metal, because electrode wire and workpiece are made up of same material. So because of that alloy content, it is said that alloys are stronger than the metal. So because of that, whatever the weld bead is the strongest part of the complete weld bead geometry. After that, if we talk about heat affected zone, it is the weakest part. Why heat affected zone is the weakest part? Because my dear, when you are putting electrode with the workpiece, heat is generated. Temperature there increases and the nearby. Why heat affected zone is the weakest part? Because my dear, when you are putting electrode with the workpiece, heat is generated. Temperature there increases and the nearby region is feeling the heating process is going on. During the welding, it is holding at higher temperature. After the welding is over, cooling happens. So the nearby region is feeling like some heat treatment process is going on. In heat treatment processes which are done to improve the properties of the material, like annealing, normalizing, hardening. So similarly, they have three things: heating, holding and cooling. But my dear, here all these three are also done, but not in a controlled manner. Because target here is welding, not the heat treatment. So because of that, maybe all three things are going here, but not in a controlled manner. They are going on in uncontrolled manner. Like if you take medicine in uncontrolled manner, it will harm you obviously. Similarly, when uncontrolled way heat treatment is done, it is not going to improve the property. That is why heat affected zone is said to be the weakest part of the weld bead geometry. You can reduce this heat affected zone by increasing the speed of welding, because then obviously less region will be affected, because welding is going on at higher speeds. So my dear, we have seen the weld bead geometry. Weld bead is having two parts. One is penetration, other is you can say reinforcement. There is also a story behind that. For that we need to go to the function of flux coating. Why we have made the flux coating over the electrode wire? So my dear, the first reason is metal have a bad habit. Whenever metal is in heated state, it is uncontrollable towards oxygen. It do not able to control itself. When it sees oxygen, it suddenly makes metal oxides. So when my dear, it will be coming in the contact of oxygen, it will make metal oxides, which are brittle in nature. So we don't want the weld bead to be of brittle nature, because we say weld bead are the strongest joint in nature. So to avoid these things, we need to control that. So whenever we are going to make the flux coating, flux is having some components which are lighter than the metal. So whenever the molten metal is, you are going to say, whenever the molten metal is going into the groove, then my dear, the flux material is coming up and making a layer of slag and then protect the molten metal inside the weld pool during the welding operation. So this is the first function of flux coating. Second function is, you said weld bead is the strongest one. Why? Because the same flux coating provides alloy content to the molten metal. Third is, flux is melting after the electrode wire. Because by doing so, obviously when wire will be melting, first it will become some concave like curvature. Because of that, the flame, spark, arc, whatever be generated, that will be having a unidirection. It will be concentrated on the welded area. Otherwise, if you are going to have wire to be melt after the flux coating, it will make some convex type of shape, and then the flame or the spark or the arc may get deviated. So these three are the functions of the flux coating. Now my dear, whenever electrode is coming towards the workpiece, you know that whenever this distance is becoming critical, then only welding start. If you will be having more gap between them, welding will not even start, because that voltage is not enough to start the welding. That condition is said to be open circuit voltage. After that, sometime you see whenever electrode is stick to the workpiece, then circuit becomes short circuit, then also there will be no welding. So open circuit voltage is the highest voltage at which current is not flowing. Short circuit current is the highest current at which short circuit happens. So there is a potential difference of 0 is present. So my dear, at both the condition welding will not happen. So my dear, first of all, the movement of electrode towards workpiece is very important. And there is another movement, that is workpiece, electrode along the workpiece, along the length. So out of these two, the first movement is very important. If both the movements are done manually, it is said to be manual metal arc welding process. If we are going to do first critical one by the machine, other one manually, it is semi-automatic type of welding. And if we are going to do both by machine, it is automatic welding. So guys, this session was only for the, you can say, principle of arc welding, which I just told you. But in the upcoming sessions, we will be joining live to have the mathematical analysis of these welding process, the equation of transformer, so that we can go for numericals also. So in this highly animated videos, we are showing you the procedures, the principles, what is going on. And in the live session, we will be meeting for some numerical part, some derivations, which will help you in GATE examination. So a combination of both will help you. So guys, to have such type of videos on some other topics, if you want, you can mention that in the comment section. So stay tuned with us and share these types of videos with your friends also, so that they can also be benefited. So this is an initiative taken for your better understandings. So goodbye guys for this session. Stay tuned. Thanks for joining.